Example 3, we go. F of x equals negative square root of x minus 4 plus 9. And again, let's identify a, h, and k. A is in front of the square root, so that's negative 1. H is inside, so that's going to be a positive 4. Yes, it's opposite of what you think. So that's what happens when it comes to h. Now k is not the opposite. K is the same exact value. So immediately, let's state h and k, 4, 9. What else can you do? Of course, the transformations, right? You got 3 of them. The negative, it's a vertical reflection. Or you can say reflect over the x-axis. Number 2, h is going to be, it's a positive 4. So that's going to be right 4 units. K, it's positive 9. So up 9 units. Oh my. All right. Let's go and do the parent function. Yes, I want you to graph the parent function every time. Y equals square root of x, especially students in your homework. So the more you practice in your homework, okay, the better it is for you to prepare for your test, right? So I'm going to pick all the inputs. Inputs are the values that you can actually use, or I'm sorry, choose. So you choose these. Now you want to choose smart values, like because we're graphing square root. These are square functions, so you want to choose perfect square. So 0, 1, 4, 9, 16. Those are the 5 inputs I want you to pick every time because they are easy to do outputs. All right. So with that said, I'm going to get a different color pen to make my transformation table. If you have an h value, then you're going to change the graph horizontally. Okay, since h is 4, it's translating 4 units to the right, so we're going to add 4. The negative 1a is going to get multiplied to the y because of vertical change. The k is going to be 9. That's a vertical translation up 9 units. So anytime you're doing anything vertical, it's going to change the y-axis, all right? Okay, again, similarly, I want you to take a minute, take all the original x values, add it to 4, take all of the parent function for y here, and transform it by multiplying the a and add the 9, all right? Okay, so hopefully you guys have 4, 5, 8, 13, and 20. On the output, hopefully 0 times negative 1 is 0, plus 9 is 9. 1 times negative 1 is negative 1, plus 9 is 8. 2 times negative 1 is negative 2, plus 9 is going to be 7. 3 times negative 1 is negative 3, plus 9, that's going to give us 6. 4 times negative 1 is negative 4, plus 9 is going to be 5. So let's plot our new values. So 4 is now going up 9, okay. 5 is now going to 8. 8 is going to 7. 13, I am going to extend my grid a little bit. 13 is going to 6. Okay, now if you want to, you can extend your 20, 5, or you can just kind of eyeball it if you want. So I'm going to do, okay, if that's 10, 20, 5 is over here, just like that, okay? This is what it looks like. I'm making my dots bigger. There you go. Looks like it's an upside down eyebrow curve because we did say that it was going to have a reflection. So let's fill out the chart. X-intercept. Now, even though right now, students, we can see that we don't see it right now the way that it is. We can tell that it's not touching the x-axis, but eventually it will. So we do have to work the find the x-intercept algebraically. So let's do that down here. X-intercept is when y equals to 0. So if y equals to 0, is 0 equals negative square root of x minus 4 and then plus 9. First step, subtract 9. So we are going to subtract 9 from both sides. So a negative square root of x minus 4. To get rid of the negative, we will multiply both sides by negative 1. So this is now a positive 9 equals square root of x minus 4. Square both sides. Okay, so this is 81 equals x minus 4. And add 4 to both sides. So now x is at 85. This is why we don't see it on our graph. The function itself will intersect the x-axis at 85 units over. So we don't have 85 tick marks, so that's why you don't see it, okay? Y-intercept, okay, because we started at 4 comma 9, it will never, ever, ever, ever touch the y-axis. Therefore, we don't have any y-intercept. The domain is, we are going to start at 4 and goes to the right indefinitely, so inclusive 4 to infinity. The range, remember, it's going downward, so we want to start negative infinity, and the highest value it has is 9. So we want to write it from small number, comma, bigger number when we're using interval notation. It is decreasing, okay, over the entire domain, which is positive 4, comma, infinity. Again, it's decreasing because it's going downward, right? It's decreasing. Now, because it's decreasing over the entire domain, then you have nothing left for increasing. So I'm going to erase there you go. It's a 1-to-1, okay? We do not have a minimum, but we do have the highest value, and that highest value is a maximum at 9. So maximum is 9 at x equals to 4. And again, can you see that it's the HK value here? The reason we don't have a minimum is because this arrow right here will go down forever. So that tells me that we can't really say there's a low value at some point because it doesn't stop. Okay, and guess what, guys? That's the end of the eyebrow curve. We'll see you next time.